Welcome to Calculus Solutions, where you will find limits, derivatives, integrals, and practical applications. Let's solve this derivative. This is the derivative with respect to x of the function 4x to the power of 4 minus 5x cubed plus x squared over 4 minus 1. We can see that this is a polynomial of the fourth order with the linear term missing. How do we start? When working with the derivatives of polynomials, we need to focus on two things, namely exponents and constants. We have here fourth power, cube, and square. In front of each term, there is a constant, namely 4, minus 5, and 4 in the denominator, which is 1/4. We also have minus 1 here, which is not connected to any x. The first step is easy. Find all isolated constants. Their derivative is always 0. That means that this term vanishes. The resulting function is slightly simpler, and it is 4x to the power of 4 minus 5 cubed plus x squared over 4. Now we need to apply a formula for derivatives of the polynomials. We will use the standard formula. It is simple and confusing at the same time. It is simple because the only relevant thing here is the exponent. The confusing thing, especially for the beginners, is that it will appear in two places. The value of the exponent itself will become smaller by 1. And at the same time, its original value will appear in front of the expression. We will now do the same technique 3 times, because in our function we have 3 terms with power of x. The fourth power will become the third power, or cube. But do not forget to put 4 in front of the expression. Then the cube will become the square, and again, number 3 will appear in front of the expression. And in the last term, the square will become a linear term, and the number 2 will appear in front of the expression again. The last step is to combine all the constants. Then the result will be 16x cubed minus 15x squared plus x over 2. Let's visualize the situation. In this picture, we can see the graph of our original function. It is a polynomial of the fourth order, and the graph is a nice smooth curve. If we plot its derivative in the same graph, we can see many interesting features and relationships between the original function and its derivative. For example, at the points where the derivative is 0, we have the stationary points. For different functions there are more options, but in this case we can see 1 point of inflection and 1 minimum. Also, there are 2 intervals where the derivative is negative. That means that on these intervals, the original function is decreasing. We also have 1 interval where the derivative is positive, and that means that the original function is increasing. Of course, we must realize that the graph is only a consequence of the previous calculations. Derivatives are here to evaluate a lot more. You can assess the shape of the function, stationary points, trends, discontinuities, tangents, normal lines, behavior at infinities, and a lot more. You can check how to do this in my other videos. So we solved it. Leave a comment, subscribe, and keep practicing calculus.